I'm Emily Haggstrom. I'm a sales engineer from InterSystems, and I'm here to talk to you today about containers. So I'm sure you've all heard of containers to one degree or another at this point, and my goal today is just to try and demystify the terms and concepts behind containers a little bit and help you understand how you might be able to use containers as part of your software development and deployment process and streamline your systems a little bit. So, for starters, what is a container? So in short, a container is a standardized executable unit of software, including all of the required libraries and dependencies that you might need to run it. And to understand this concept a little bit better, we need look no further than the shipping industry. So prior to 1956, all shipping was done using loose boxes and barrels. It was back-breaking and time-consuming work to get all of those individual units of goods loaded and offloaded off of boats and trucks and cars. And until one day, a man by the name of Malcolm McLean said, there has to be another way. And he started up his own independent shipping company, did a little bit of research, and before long, the shipping container was born. So the shipping container provided a standardized unit of transporting goods that could be moved from truck to train to giant freighter. And everybody knew how to store them, how to move them, how to work with them. They built all of this machinery to help with loading and unloading, and almost overnight, the shipping industry saw dramatic improvements in efficiency, in their time to deliver, and in safety. And this is effectively what containers are doing for software today. So how do containers work? Basically, a container is a sandbox environment for an application to execute in. That includes everything that application needs. So it might include maybe an OS that you want your application to run on, lightweight version of that. Any code libraries or any other utilities your application might be dependent on. Files, images, your compiled application code ready to run, maybe even an embedded database. It can include almost anything that would encompass your entire application environment. So once a developer has crafted this environment and it's all working to their satisfaction, they can capture this as a container image. Now, a container image is basically a binary representation of your executable application environment. This can be duplicated, it can be versioned, it can be stored in repositories, and it can be distributed as widely as you might like to get it to anybody who might need to use it. Now, there's one more piece of technology that you need to make containers work for you, and that's a container engine. So remember we talked about all of those machines that they developed to move the containers from one place to another to help with loading and unloading and stacking these things. That's where Docker comes in. There are other container engines out there, but Docker is the industry standard right now because Docker created a suite of tools and paradigms for working with containers that made them really easy to integrate into an application development lifecycle. So does anybody have any questions so far? Okay. So let's talk about Docker a little bit and what Docker does and how Docker works. So Docker solves a number of problems. Docker solves software packaging with the concept of the Docker image. solves distribution through Docker registries, which a lot of companies are using to deploy their software directly to end users. And it solves execution by providing the Docker engine, which is a universal platform for running containerized software. So in order to build a Docker image, it all starts with a Docker file. Now, a Docker file is essentially just a text file that includes a list of instructions that Docker is going to need to execute to build your container image. You tell it what files to pull in, if there's software that needs to be run, environment variables that need to be set, anything else that Docker would need to know to build that full image. So then you run a Docker build command, and you get your image. And this is the image that can be distributed. And so then once you've got your Docker image that you're all happy with, you can do a Docker push command to load that up to a registry. Now, these registries can be private registries, one that is for your own personal use, for projects that you're developing that you're not ready to share with other people. They can be private to your own company, so you can share development projects you're working on with the rest of your team, or internal applications. And they can also be public registries. So a lot of companies are posting their registries up on the cloud and publishing them so that users or developers can go out and pull down the containers for the applications that they want to use anytime and get moving with them relatively quickly. So once you've got your images up on the repository or the registry, you can do a Docker pull command to get the images that you're looking for. Once you have those images on your local system, it's just a Docker run command to turn that static binary image into a fully executable environment. If we're talking about this sort of as an object-oriented concept, a Docker image is kind of like a class definition, where a Docker container is an instantiated object of that class. Any questions so far?
Exactly. What is it that you're instantiating? Is that an instance of a server, or what instance of a process? What are you instantiating?
So it's an isolated execution environment. It's a little bit like a VM, but I'll get into the differences between a container and a VM a little later. And yeah, it's an executable process. Yes, there's a microphone in the back if you want to use that for questions, so that they'll get on the audio recording as well. Yeah, and I'll show you that in a little bit. So a registry is going to contain, or a repository is going to contain any number of these registries of different containers, and that can contain any number of different versions of these container images. So you can pull exactly the version down that you're looking for. So let's take a minute and see how some of this works in action. So I've installed Docker for Windows on my computer. Docker exists for Windows and most platforms of Unix, and it runs as a command line interface. So if I pull up a command line, I can just do a Docker version to show you the version of Docker that I have installed on my system. And I'm going to go ahead and make this bigger. Okay. How's that? Easier to see? Okay. So when you run a Docker command, so let's say, for instance, I want to do a Docker run. It's going to check for local libraries of Docker images that you have on file already. And for anything that it doesn't find, it's going to go out to the Docker hub, which is the master Docker repository. It's going to see if it can find that and pull it down for you. So I'm going to do a quick demo here, a very simple one. There's a Docker container out on the website for your use. It's called BusyBox. It's a very simple container that just runs a command. So for instance, I can do docker run BusyBox echo hello. And so since I already had the copy of BusyBox on my system, it's just executing my command, and then the container stops. I can take a look at all of the Docker commands that I have, all the Docker containers I have on my system by doing a docker container ls, and you'll see I've got nothing running right now. If I add the -a, you'll see I have a couple of instances of a BusyBox container that have run and exited a little while ago. So that's a very basic container, an example of something super simple you can do with a container, but I imagine it doesn't have a great tie-in with anything that you might want to do with your development processes. So let's take a look at something that's a little bit more involved. So let's say you wanted to build a container to host a PHP web application. So I'm going to start by just writing a super simple PHP Hello World web page. Okay, and I'm going to save that as index.php into my source folder. Okay, so now I want to build an image for a container that's going to run this website. So first thing we have to do is we have to create a Docker file. So I'm going to create a new text file, and I'm going to save this as Docker file into my Docker folder next to my source folder. So I'm going to save that, and because Windows thinks it's smarter than I am, I have to go in here and take off the txt extension. Okay, so that's the Docker file that we're going to work with. Now, building a container with PHP libraries, web server, all that would be a little bit complex, but fortunately, we don't have to start from scratch. The Docker Hub is full of thousands of containers that have been published by other application providers and vendors for containers for your purposes. So if we go to hub.docker.com, and we go to Explore, you can see there are a whole bunch of different containers out here with MySQL, different versions of operating systems, other utilities you might want to use as a basis for your own containers. In our case, we're looking for something with PHP. So I'm going to do a search. And I see here there's an official repository for PHP. That's been verified and vetted, and that's the one we're going to want to use. So if I open up that repository, you'll see in here there are a number of different flavors of this container image out on the Docker Hub. Now these all represent the container built on slightly different versions of the PHP library, maybe different utilities that are included in them. They could be based on different operating system platforms. In this case, we're looking for something that includes an Apache web server. So let's just do a find Apache here. And let's see, 7.3 is the release candidate, so I think we're looking for the latest stable release that includes Apache, so that's probably going to be this 7.2-Apache tag here. So in my Docker file, I just have to say from PHP dash or colon 7.2 dash Apache. And I don't need to download anything to do this. When I do my Docker build command, Docker's going to go out and look for that, the container matching that tag, and it's going to pull it down for me. So that'll get us the base image that we can work from. And so now we've got our PHP libraries, and we've got our Apache web server. So what else do we need to get this website running? Well, we're going to need our source code, right? If you scroll down a little further in the PHP repository on Docker Hub, there's actually a bunch of reference information for how the container works and how to use it. So if we look down at using it with Apache, it'll show you that it's going to be reading the source code from this var/www/html directory within the container. So I need to copy my source code from my source folder to this var/www/html. And then there's one more thing that we have to do as an instruction in our Docker file before we can build this image. Because we're hoping to run a website through this container, we need to expose a port on the container that it can listen on. So I'm going to tell this that I want it to listen on port 80 for web requests. So the command for that is just expose 80. And that's it. That's all we need in our Docker file to build this application in a container. So I'm going to save that. And the next step is going to be to actually build the image. But before I move on, I'm going to take another pause for questions. Everybody follow what's going on in this Docker file? Questions on that? Okay. All right, so I'm going to navigate to the folder where my Docker file lives. And then I'm going to call Docker build. I'm going to use the -t option to give it a name. We'll call it Hello World. And then I need to tell it where my Docker file is. And since I'm already in this folder, that's just my current directory. So now I actually already pulled this PHP 7.2 Apache container earlier because I don't trust the internet in the conference rooms. But had I not already done that, it would have said that it was unable to find that container on my local system, so it would have gone out to the Docker Hub and pulled down that PHP container for me. So it's using that as the starting point for the container. It's copying in my source code, exposing port 80, and now I have a running container. Or no, I have a, sorry, do not have a running container. I have an image. So if I do Docker image ls, you can see I've got my PHP image right here. I've got my hello world image that I just created from that PHP. And if you look at the size of those two images, they're pretty much the same because I've just added a little bit of code to that existing container image. And I've also got my busy box down here from the demo we did just a minute ago. But you remember that an image is just a static file. So if I actually want this website to run, I need to run my container. So that's just a Docker run command. So we're going to do docker run hello world. And there's one more thing that we need to do here. Yes? Docker run. Ah! Thank you. Okay, my container is called hello word. All right, so there's one more thing that we need to do here because we're running a website, which is, it's not enough that the container is listening on port 80. I also need my laptop to listen on to listen for the web request as well. So I can use the -p option with my run command to publish a port from the container to my own computer. So port 80 is already in use on my computer, so I'm going to do port 8080 to port 80 on the container. So this is going to mean that my container is going to be listening for any web requests that come in port 8080 on my computer. Yeah. So I pulled a PHP container image that included Apache as well. So they built that for our convenience.
So the port exposure basically right here is like internal portfolio.
Right. Right, so the -p command is publish, and it's basically it's connecting a port on the container to a port on my computer. So if we run that, we get a couple of warnings here about server variables that aren't set, but that's not a big deal. And now if I go out to localhost, port 8080, I see my web page. So that's about how long it takes to get up and running with a new container completely from scratch with a new application. So questions at this point? Well, stay tuned for that. There are a number of other sessions today that are going to cover InterSystems products with the container technology.
With regard to the registries, I mean, you went to a public one, so you obviously connect to your own private registry.
Yes. So by default, it goes out and looks at the Docker Hub if you don't give it another registry to look at. But you could log into your own private registry and tell it that you wanted to pull from there.
How do you run, I guess, a different server or something else for that, for your own registry?
So it is possible to set up a private registry on Docker Hub, so you don't have to set up something yourself. A lot of larger companies will set up their own managed registries.
I was thinking like with Maven, you could run your own Nexus internally.
Mm-hmm.
Maybe the corporate pulling stuff that you may not want from a security perspective.
That's a good question. Could you share your question again with the mic, please?
So my question was regarding public versus private registries.
Mm-hmm.
So I was asking, how does this work where you can set up your own private registry? Do you have to run your own software or something? And I'm just looking at this from the perspective of, I come from the Java world, working with Maven, so you can go out to the public or you go to your corporate one. So it seems like it's possible, but I guess more detail to come.
Yeah. Luca, do you want to address that?
We actually have a private registry systems with our hub and registry where we do have our local store. So you can set up your own registry. Docker is one of them. Every single public cloud provider has already their version of the registry that you're utilizing. That's one of the richness
Question in the back? That answer for anybody who didn't hear that was Docker offers a registry container that you can make use of. All right. Okay, so just to cover at a high level, in case I haven't said it in so many words, what are the benefits of working with containers? So first of all, and probably the biggest benefit of working with containers is portability. Solves the age-old problem of, it worked on my computer. Since a container is encapsulated application environment with all of the libraries and dependencies that it needs to run, you can very quickly and easily pass this on to from development to test to production. You're never going to run into that problem of, well, it worked on my machine because I was working with Apache 2.2, but test is using Apache 2.4, and now apparently it doesn't work anymore. And straight on down the supply chain to your end users. Whatever their home computers look like, their enterprise computers look like, your container is always going to run in the same environment. It's also really useful for a migration strategy because they run the same on bare metal VMs or any cloud provider. So if you've containerized your on-premise environment, it can make migrating to the cloud a much simpler process. Another benefit of containers is efficiency, particularly when compared to a VM paradigm where each of your applications is running in a encapsulated VM environment. So with your VMs, you've got your server, your host OS, your hypervisor to manage all your VMs, and then each one of your VMs has a new full version of an operating system on it, all of the utilities and libraries that your application needs, and a copy of your application. When you use containers, all of your containers are sharing the same system level resources of the host operating system. The Docker engine is smart enough to know that if you've got 3 containers running that all use the same version of the Java runtime environment, it doesn't need to replicate that 3 times. So it saves space and it utilizes your system resources much more efficiently than distributing your applications across VMs. Yes?
You mentioned earlier about having some form of operating system, but you're sharing the host.
Yes. So, great question. And the question was, I mentioned operating systems in containers. So, that's optional. You do not need to include an operating system in your container. But a lot of the times, if you want to include operating system utilities and commands, command line interface, things like that, you may want to include an operating system layer in your container. It's still utilizing the same kernel and system level resources as the host operating system.
So could you have disparate operating systems?
Yes.
See, that's where you can, because you say it uses the same kernel as the host, but if they're not the same kernel, it can't be.
Right. I'm going to turn that one over to Joe.
Yeah, so when we say host operating system in your kernel, we're talking about, for example, Linux. So when we're talking about operating system in your container, we're talking about binaries and libraries specific to that flavor of Linux, but not collectively. So there are Windows containers and there are Linux containers. These are sort of separate technologies that share a bunch of the same properties. But fundamentally, you have multiple of these containers which are running correctly. So you can have
So for instance, the container that I ran is actually a Linux-based container, and I'm running it on Windows. So a lot of these are about how it determines the server name. It's a warning that you need to set some additional system-level parameters if you want it to be able to reliably determine the server name. And also, there's a warning in here about how permissions are handled between Windows and Unix. So there's a couple of compatibility issues if you're running a Linux-based operating system on a Windows environment, but it does work. All right, and the final big benefit of working with containers is scalability. So duplicate container instances can be spun up in seconds. As demand increases, or if you need to onboard new developers to your team, you can get people up and running very quickly. Containers can also be discarded once they've finished the task that they were deployed to handle. So this model is very complementary to the elastic deployment model that a lot of cloud providers are using these days, where more servers get spun up to handle demand and then discarded when the demand goes back down. All right. Now, I want to touch briefly on how InterSystems is working with containers so far, although you're going to hear a lot more about that later today from some of the other presenters. So far, this is what InterSystems has in containers. The InterSystems Iris data platform and all future versions of it will be available in containers in addition to the current distribution methods. We also have some of our add-on utilities like the Web Gateway, the Arbiter, and the InterSystems Cloud Manager, which is our cloud orchestrator tool, are also available as independent containers. These slides will be available after the presentation, so there's a link in here to where you can access all of the containers that we have available. And we're in the process of migrating our containerized products to all of the major cloud marketplaces. And now, so to present a real-world account of working with our InterSystems containers, I'd like to present Diane Steidler from Partners Healthcare, who's been working on a deployment of a project using Iris in containers.
Okay. So my name is Diane Steidler. I work for Partners Healthcare. I manage the HealthShare and the Health Connect platforms throughout Partners. And over the past couple of months, we've been engaged in a pilot project where we have migrated this Biomedical Repository application to Microsoft Azure cloud environment using Iris containers. And first, just a couple of words about Partners. We're a very large integrated healthcare delivery network in New England, and we have hospitals throughout Massachusetts and now into New Hampshire and Rhode Island as well. And we serve 1.5 million patients annually. And here's some more interesting numbers about Partners. So let me start with what is this Biomedical Repository? Basically, it's just a very large database of biomedical data that comes from medical devices throughout Partners. So these are basically bedside monitors, respiratory monitors, and things like that. The data flows into a Ensemble production, which is running in HealthShare, and that's through HL7 messaging. And the data flows into the patient's medical record, which is currently in Epic, and it also flows to the Biomedical Repository. And the repository is available to use for research, clinical decision support rules, and analytics as well. So because it's a lot of data, the repository has been growing pretty rapidly over the past several years, and it's currently at 5.6 terabytes. And because we have a mirrored configuration. We actually have 4 copies of the database. So our real main motivation for going to the cloud is to push this storage up into the cloud environment and save on storage costs. So the first goal was indeed to just move the repository up to the cloud, be able to grow more organically in terms of storage as well as other system resources. And then secondly, to leverage the IRIS data platform, particularly the containers in the ICM tool, which Emily mentioned, for quickly and consistently provisioning an entire environment. Okay, so we use this to provision an infrastructure as opposed to just an individual application. And then finally, just our goal was to gain as much experience as possible with the different cloud vendors, with cloud technology, so we could establish some best practices and use this for future applications. Okay, so then we had some specific requirements for a successful pilot, and in the interest of time, I'm not going to go through all of these, but certainly security is very important if you're moving PHI up to the cloud, performance, availability. So these were the requirements that we established early on, which through the course of the pilot we were able to realize and be successful with. Okay. So we use this cloud manager tool, the ICM, to provision the infrastructure. And to do this, you simply take these JSON files, and this is where you specify what you want your environment to look like. So if it's, for example, how much storage you want, how many CPUs, memory, the names of your instances, whether you want mirroring or not. So it's very configurable simply by editing these files. And then you run the Cloud Manager, and it pulls the image or the IRIS container. We actually pushed an IRIS container and the ICM container to our own repository, Docker repository that we created. And so we provisioned that in the matter of 10 minutes. It just spun up the environment, virtual machine, the storage, the virtual network, the IRIS container. And we provisioned this in 2 regions, the East US region as well as the Central. And we configured mirroring, so we have a disaster recovery solution between the 2 regions. And then in terms of running your application, you can we ran HL7 messaging to the Biomedical Repository that's now running in the cloud, Microsoft Azure Cloud, as well as other applications using HTTPS. Okay, any questions so far on that? And so this slide is just sort of a depiction from the application level. So we still have the on-prem, the Ensemble production is running, it's still populating Epic as well as the local repository. So we're running this in parallel. This is our live QA environment. We're running it in parallel in sending the messages off to the cloud, the IRIS container where that repository is also getting updated. So while we evaluate the costs and performance and whatnot, we'll be running in parallel, and then we'll dismantle the on-prem databases and save on a lot of storage. Okay. And then finally, in terms of some lessons learned, I found it pretty amazing how quickly you can provision an entire environment, entire infrastructure using that Cloud Manager tool. Traditionally, it can take weeks or months to get your systems configured and the cabling and the network and everything, but this literally takes less than 10 minutes to create an entire environment. And you can re-provision as needed. We did that quite often, pulling down new images, new IRIS enhancements and ICM enhancements. So it's, you can re-provision very quickly as well. We found that, because the ICM tool is so powerful, it really required a lot of coordination with different teams within the partners organization, because, typically we have a security team that works on the security end of it. We had a custom Red Hat image that they created that was hardened with some security enhancements. So fortunately, the ICM tool is very configurable, so you can leverage existing resources. So in addition to being able to spin up, all the resources like the virtual network and the storage and the VM, you can also configure it to leverage existing images or virtual networks as well. So it's very, very configurable. In terms of cost, we're continuing to do a cost analysis. Microsoft Azure has a lot of good tools for assessing costs, but it's a little harder to figure out what your costs are on-prem, so you can do a valid comparison. So that's sort of ongoing. So the pilot was very successful, and our next steps are to look at the sharding technology and take advantage of the performance enhancements that go along with that, backup solutions, and then we're going to start provisioning the Biomedical Repository in our production environment. So, any questions?
All right, so hopefully this whet your appetite for containers a little bit. Particularly the stuff that Diane was saying about working with ICM. Immediately following this session in this room, there will be another session called Fast Provisioning in Any Cloud. That's going to be hosted by Joe, who's sitting over there. And he's going to talk a little bit more about how the InterSystems Cloud Manager works and how it can be used to manage your deployments. We also have another few sessions later in the day on working with containers. So tomorrow and Wednesday, there'll be a session specifically on working with InterSystems Iris in a container. And another session on Tuesday and Wednesday that will cover using containers for a continuous delivery process. If you're interested in learning more about Docker and containers on your own, training.docker.com has a number of hands-on, self-paced hands-on exercises that you can use to play with Docker and containers. Learning.intersystems.com has a number of sessions about working with InterSystems products, specifically in containers. If you visit community.intersystems.com, that's our developer community, and you can have conversations with other developers out in the field who are working with containers. There's a link here to one specific page in our documentation, which is the first look InterSystems products in Docker containers. And that is intended to be an intro-level walkthrough of using InterSystems products in Docker containers. So that's a great exercise if you want to dig into this a little more deeply. So does anybody have any questions on anything that they saw here today? Yes?
I have one. So when you were demonstrating the Docker running the Docker file, so that's an instance of Docker running this file. Once everything is up and running, and let's consider everything is just Windows to Windows system, no Linux overlap. If that process dies, does everything die, or once your patches are up and running, does it stay, or is everything just within that one context if it dies out?
So once you've got a Docker container running, you can stop that container, and it will save the state of the container. So if you start it up again, you can pick up where you left off. If you remove a container, everything that you've done in that container will be lost. It's not automatically saved to the image. So there's a couple of ways that people handle that. You can do a Docker commit to take changes you've made to a specific container and create a new container image from that. There's also a way to mount local directories so that you can do development work on your container without actually making changes to the container itself. Yes. All right, so unless there are any further questions, thank you very much for coming today. And please don't forget to fill out the survey. And you can find all of these slides on learning services at learning@intersystems.com after the summit.